Yes, okay. Hello, guys. Good morning. The class bell has rung, so let's begin our today class. Yes, and in the last class, yeah, today we still have the class online because of the COVID policy that our college that still require us to have the class online. So I record these videos for you. So I'm not sure that students download videos to review or not, right? But the last class, we have finished chapter 5 about column design. So, yeah, some students may feel, yeah, this chapters is quickly or sooner or very fast, right? Faster than the previous chapter. Yeah, that's correct because the previous chapters we just lay foundations for us to master some property of material, but this chapter we learn now is for design about calculation. So just use some examples brings you. So yeah, we just to finish that. Okay. At the beginning, right? At the beginning, we will have to review. Yeah, to review what we learned in the chapter 5, and just begin the chapter 6, right? This week is the 5th week, and the students need to know we may have the test near the 18th, right? 18th week. Okay. Yeah. For the column design, we use a useful chart. Yeah. Now I ask questions to you. For students listen or watch the videos, you need to recall that what's the useful chart. Okay, I will show and here to use a useful chart that we called it the MN interaction curve, right? It had a shape look like this. I'm not sure students remembered it or not. Yeah, but it's a request to you to master it. You need to remember that the curve, okay? For the curve, we introduced 3 failure mode. For one is a balanced failure mode. For columns, only just 1 point, right? 1 point is balanced. What's a balanced failure is the concrete and the steel bar, they reach the field at the same time, right? At the same time. And the previous, and the higher is the compressions failure mode. For the lower part is the tensions failure part, failure mode, okay? For columns, right? For column design, we need to know it's always under the axial force with the bend moment. So for section on the columns, they always had compressions, right? Compression stress. So for mode, it may around in this part, right? This part. Yeah, if the columns failure at this point is the best, right? But it's hard to reach that. That's the things, that's the things we need to know at first. Only we master that, then we can continue to do the structure design or to do the column design. And in the last chapter, after we learned MN interaction, right? We talked about short columns and the longer columns, right? Here we bring an index. I'm not sure that you know or not. Index about what? Slenderness ratio. If students forget, okay, doesn't matter because I shared the PPT in group. You need download it. Okay, the slenderness ratios lambda, right? Lambda, and for lambdas, we compared this index with the shear limit. Okay, for calculate, right? For this index, for calculate slenderness ratios, we bring a effective height L0, right? L0 to divide I, right? It's related to I divide A. That's the characters parameters about the section. And for the limit, the slenderness limit, do you remember the AB3? It's related to empirical factors. We need to check it from the code. If the slenderness ratio is smaller than the limit, we name it the short columns. And if the lambda bigger than the limit, we name the longer column. What's the difference between the short columns with the longer with the long columns is that second order effect, right? Second order effect. If the columns belong to the short columns, that means we do not need to consider the second order effect. But it belongs to the long columns, we have to consider the second order effect. These things means the expressions what we used is different, right? Okay, and talk about effective height L0. We know it. It's related to the boundary, right? For column boundary. If it hinge and the roller, the effective height equal to exactly the height. If the fixed, right? The fixed of the one side, another side is a free. The effective height is equal to 2 times L, right? L means his original height of the columns. And what else is the two-side fixed? Two-side fixed. This effective height equal to half of the original height. This is about effective height that we will use it in the columns judgment. Colors judgment. Okay. Now after we learned that, right? We learned that. Okay. Yes, this is about chapter 6. Right? After we realize that, we talk about the expressions, right? Expressions. What we all do at here is get the design moment and the design axial force. If we know the moment and the axial force in the columns, we will use MN chart to get what we need, right? Because here I introduced this chart for us to get the reinforcement element, reinforcement area, right? Area. They will relate it to values, maybe or age, and then from these equations we can get AS, what exactly the area we want. Okay, I summarized in chapter 5 because here is a two big examples for you, and I hope students can read the examples carefully. And okay, I summarized the calculation steps or the design procedures for you, and I hope students here just maybe followed my flow step, and when in the futures, when you design, you can follow this step. Okay. One thing is we need to simplify the models, right? Because in reality, the structure or the buildings we face will be complicated. Yeah, it doesn't matter. We use our knowledge. That knowledge may learn from the material mechanism of the structure mechanism, and we can simplify the reality buildings as a frame structure, right? Frame structure, like this, right? Look like this, and consider the load applied to the structure. This chapter, this semester, we do not talk about the wind load or the living load or the dead load. We just know the values, right, directly applied to the structures. Yeah, after we simplify the structure, whole structure, and know the load, how much load applied to the structures, what we can get is that we calculate the moment, internal force of the structure, like moment, axial force, and shear force, right? Shear force. And for columns, right? If it not suffer the wind load, only the gravity or the living load, so there's a no horizontal load. So the shear force we will do not considered here. So only the moment and the axial force that we can get. For the axial force, NED may easy to get, right? Because it's along the columns. But for the MED, do you remember that we introduced in the short columns? They related to the sides. Always a maximum moment occur on the side, right? On the connectors. Yes, multiply. Eccentric E and multiplied ED, right? Because this one related to the construction area, so the deviations of the construction, this area bring in the structure will cause the additional moment, right? And then how to calculate this is essentially there is an empirical formula for us. It's the L0. That's effective height, right? Effective height I illustrated before. Divide, L0 divides 400. If student forget, okay, please go back to review the PPT. This is for the short columns, right? Short columns. After we calculate the NED and the MED, we use the chart, MN chart. This curve may obtain from the lab, right? From the lab. And the curve should contain the point what we designed, and get the AS, right? And what the difference between the long column is that if we calculate this one, it's not enough. What we need considered is the second order effect. How to calculate the additionals essentially that based on some empirical formula, right? And what's important procedures during the long column design is that iteration, right? We need assumed K2 as the values at one point and substitute these values in the procedure calculation, the formula calculation, and then get K2 and compare these values. Only these two values close, they had the same values, yeah, then the iterations is over the end. So this is about difference between the short column design with the long column design. Yes, I hope students to go back to read the PPTs, and if during this during the revision, right, during your studies, if you have any problems, I welcome you. Yeah, welcome you come to my office to talk with me in details. Yeah, after the chapter 5, yes, chapter 5, what we have learned after chapter 5, we have talked about flexure beam design and the shear beam design, right? Shear design of the beam, and also the column design, right? Columns, to just look at here. Flexures, shear design, and the columns. Yeah, students may feel, yeah, it's so difficult. But I have to say, this is just a basic knowledge for you, right? For one day you go to work, you need familiar with the things what we learned today, and this knowledge will guide you to do the structure design and to build the buildings, right? To build buildings. Okay. See much about previous knowledge, and this semester we will talk about the detailings and the serviceability, right? Serviceability. Because for previous, the chapter 3, chapter 4, right? 3 or chapter 4. What we talked, just if the compatibility of the structures smaller than the load, the structure will fail. Yeah, it's belong to the ultimate limit state, right? Ultimate limit state means if the capacity not satisfy the load, the structure will be broke, be failure. But do you remember what things we talked in chapter 2 is another limit state? That about serviceability limit state. That means serviceability limit state. Structures reach to the serviceability will do not fail, but it affects appearance, affects people use it. Right. This is the serviceability limit state. Just like had a large deflection or had cracks occur on the surface. Yeah, what else? Another things, right? This is belong to the serviceability limit state. And in chapter 6, we will talk about this limit state. Only the structure satisfies the ultimate limit state and the serviceability limit state. Then the structures we can see it's a good quality structure. Yes, look at here. Here's divided 4 sections. One section is about detailing requirements. Yeah, for serviceability limit states, we just have a quickly a brief review about what things we cared in the serviceability limit state. For SLS, they those aspects, like deformations that affect structure's appearance. Yeah, before I use the examples. Do you remember or not? I use a bridge. For bridge, cross the river. Cars move from a car. A car passes through the bridge if the bridge has a large deformation. May the bridge can bear the load of the car, but if the bridge has a large deflection, the people drive the cars on the bridge, they may feel uncomfortable, right? And I had to use a, right, this is a car. Yeah, previously it looked like this. Yeah, if it had a large deformation, people will scare, right? So the deflection is belong to the serviceability limit state. And also the vibration, because vibrate so quickly, just like an earthquake comes, the people living in the buildings will feel uncomfortable. And what else is the damage like the adversely affect appearance? Appearance, just like the cracks. If for buildings, there's a lot of cracks. It may feel it's dangerous. People living in the buildings think it's dangerous. It's not safe, right? It's not safe. Yes, this is the things, detailings that we will talk in these chapters. Okay, in the chapters about detailings about these ones. The first things we need to talk is about concrete that we used. For concrete, in the chapter 2, we know it consists of the cement, aggregate, sand, and the water, right? What important ratio is about the water-cement ratio, right? Water-cement ratio will affect the liquid of the concrete. If there's more water, that means the concrete flows smoothly. But if the water is small, that means it's hard to smooth. Yeah, we need to realize that also different ratios of these ingredients, they will affect the concrete strength. And I know the students during the studies, you may have do some experiment about to mix the concrete. The teachers will teach you how many waters need you to use to mix the concrete, and how many aggregate and how many sand. Yeah, because of during the learning, teachers tell you, right? But in reality, you go to workplace, there's no others guide you. You need to read several code or the books, to use your own experience to make the concrete. So remember, this concrete, mixed, will affect the behavior of the serviceability of the buildings. Okay, buildings. And talk after that. What another thing important that we need to know is the cover. Cover. I'm not sure the students still remember or not. For singular reinforced beams, we always talk the effective depth, right? This is the D, right? We do not mention this one. This is the cover. We use the C to represent. This is the cover. And For this is the beam. For columns, right? They also have the covers. For the function of the covers, we know it can protect steel bars. If there's a no cover, that steel bars will expose to the environment. So it will affected by the environment. If the structure with the cover, that means the steel bars inside, they will not easily affected by the humidity, right, or waters. These things will make steel bars robust. It's not good for the steel bars, right? So the function of the cover will protect steel bars. Also, we know the steel bar had the door action affected. So if we add the covers or the around the steel bars, they can transmit the bond stress. Another thing really important, that fire resistance. This one thing some people feel new, but exactly for us, we know if people cook in the rooms, they have the fire accident. Yeah, the fire surrounding a room, they will have actions on the wall, right, on the concrete structure. We hope, yeah, for the steel bar, it belongs to mantle, right? Mantle means it's affected by the temperatures easily. So use the concrete to protect steel bars. They may improve the structure's fire resistance. Yeah, these things will affect the cover's depth. And during the serviceability limit state, we need to consider these factors and to give a reasonable cover steps for structures. Okay, now for covers, it's a concept how to define that. It's the distance, right? It's the distance between the surface. This is the surface, right? Surface of the reinforcement close to the nearest concrete surface. Yeah, this is the reinforcement surface to the concrete surface. Yeah, to there, right? Including the links, stirrups, and the surface reinforcement near the concrete surface. This is the expression. What expression is this? Is the minimum concrete, and this is the construction deviation, because during the construction it's hard to control. They will have a deviation. So the normally the covers, yeah, had this experiment. For this one, minimum we need during the design, we need to give it, right? So they have three things will affect. One, yeah, just the bond, right? Transfer bond, and the next is the protection, prevent the steel bar and the fire resistant, and another is the minimum values for structure design. Okay, so for cover to transfer the bond, according to the code, yeah, they had the item that we need to obey. Yeah, to safely transfer the bond stress between the concrete, the minimum cover should not be less than the diameter of the bar. So the cover should be larger than the diameters of the steel bars. Okay, remember that. If it's rated, sometimes we use 20, right? 20 centimeters. So the cover should be larger larger than 20. The diameters of the steel bars. Here, for bonded bars, right, means there's not only a bar, they have several bonded bars. So the equivalent diameters should be adopted like here. Yeah, this is the number. This is the basic diameters. This is the equivalent. So we use this one to judge it's satisfied or not. And for the nominal aggregate size, because the concrete consists of the water aggregate. If the aggregate size exceeds 32, the minimum of the bond should increase 5 millimeters. Yeah, for here, this page, the items gives you the requirement about minimum covers. Transfer the bond. Yeah, for this one is important. Some people may forget. So we just choose easily the bond. So that will cause some problems. The crack will quickly occur on the structures. So if you do not have enough the covers. Another is the durability, that means protect steel bars. Yeah, look at here. For these figures, we see the covers not enough to protect the steel bars. So the steel bars rust. Yeah, rust. Look at these figures. We see there's a crack developed, and they let the steel bars expose on the environment. So the exposure conditions are chemical, physicals. Yeah. So we need to consider the durability, that the covers should protect the steel bar. I'm not sure the student go outside to see some old buildings. Yeah, old buildings, or old bridge, right? During near the bridge, we will see there's some crack developed on the surface. Yeah. That means these structures do not have enough covers, right? Because in the early stage, the China also don't have the money, not rich, right? So people want to save the materials, so the covers do not use enough. So that caused a lot of problems these days. For students, you are engineer, and in the future you should design. You need to consider that. Okay, you need to consider that. Yeah, here from the code, they give you they classify several environment for the structures. If the structure exposures on the different levels environment, so they had a different requirement about cover steps. For X0, X1, they had explanations to see. For XO means for concrete without reinforcement or embedded metals, output is expected free. Yes, this type means no reinforcement, right? No. And the dry or permanent wet concrete inside buildings. And freeze and corrosion poignant. So this is the different levels had the this chart we followed these tables, we can evaluate the environment levels. If we know the environment belong to which type, we can use this one. Use the in these tables to get the covers. And also for different concrete degrees, they have the different requirement here. This is the working life about 50 years, and what else is 100 years. According to different environment, they recommend values for you to the covers design. Okay, this is about the durability covers, minimum covers. And what else is here? Deviations, right? Deviations, sometimes we just choose the 10 because this one caused by during your constructions. Constructions mean the material used, this is a wall, right? This is a wall. And at here, people to use the toys to give the covers. And but here use another toys. So that caused the deviations of the cover depth. So at here we consider the deviations or errors. If the quality assurance and the cover is measured, we can choose a specific covers, right? And if no conforming members, just a range that we can choose to consider. If you feel the quality of the walls is good, so the covers can, the deviations covers we can choose smaller. But you think, for during the construction, it's not accurate the values we choose. So to protect the structure, at these conditions, the covers we choose can larger. The values we choose can larger. Okay, talk about that, the deviations. For what another things is about the index we according to these figures. Here is the axial distance, ASD. This is not to the surface, because reality, right? Reality at here to here is the cover, but definite axial distance according to this one. This means the steel bars not include except the stirrups, only the reinforcement, the centers to the surface. This is the axial distance, and this is the B, right? B. For the columns, the minimum column wise and axial distance should be checked based on this fire resistance. Look at here, fire resistance always considered in the column design. For you to choose a proper cover for columns, you need to consider the fire resistance. Okay, fire resistance. Okay, take a rest. Okay, stop at here, take a rest. Later we will still continue to see something about the detailing and the serviceability about this chapter.